So we've got Ruben here, so I'll try in English. Blazor. For those of you who never met Blazor and how it works, you can go to Ask Me Blazor CZ, where there is a test application. You can try that with your mobile phone or whatever. This is an application written in Blazor. If I just quickly show you what's happening there, and I will show you the Blazor is a development stack from Microsoft, where you will develop single-page front-end application using C# and .NET technologies, and the result, the .NET application itself, will run inside the browser using a technology called WebAssembly, where WebAssembly is quite new standard in web browsers, currently supported by most modern browsers. In fact, the only one is Internet Explorer, which does not support WebAssemblies. But if you try in Chrome, Opera, Firefox, Safari, it should work. The application itself, it's running on .NET runtime based on Mono, which used to be open source alternative .NET runtime written by open source community. In fact, it's Miguel something who originally wrote that for gaming and for Linux, and then the other usage scenario was the Xamarin for mobile development. And now Mono has a port to WebAssembly, so it's something similar to .NET Exe, and it's running on WebAssembly, which is something similar or alternative to JavaScript in browser, where the code itself is not like a readable file, text file similar to JavaScript, but it's a bytecode. There is a specific set of instructions, very similar to those you know probably as Microsoft Intermediate Language, the target of basic compilation of any .NET application. And it's up to the browser to implement that specific set of instructions and to provide the virtual machine, the platform for those applications to be able to run in browser. From security point of view, it's similar, or it's the same sandbox which is used by JavaScript. So whatever you are able to do with JavaScript, you are able to execute those instructions or that security context in Blazor or in WebAssembly. And there are currently some limitations. For example, the WebAssembly is still not able to manipulate the document object model, the DOM itself. So whenever any application running in WebAssembly wants to interact with DOM, there has to be some kind of JavaScript bridge which translates the communication in between WebAssembly and the outboard and passes all those changes to the DOM from WebAssembly. And what you currently see here it's the whole application. It has 5.5 megabytes of resources. In fact, it's 2.5 if it's compressed. So it's quite small, and as you see here, apart from those mono files, there is a bunch of DLL files. These are real .NET DLLs, the real assemblies, which are then loaded by the mono engine there, and they are compiled using just-in-time compilation into the WebAssembly code, which is then executed on the fly in the WebAssembly sandbox there. Those files you see here, they are quite small, and those DLL files. It's because there is it's called assembly stripping or trimming technology being used, where the build process of those assemblies tries to detect which APIs you are able to use in those assemblies and get rid of, strips all those other APIs which are not being used by your application. So it's quite a difference. The original, like few months ago, the original download was from 80 up to 150 megabytes, and now with the stripping there, it's acceptable. The development itself, it's a regular .NET code. So if I want to show you the Blazor itself, those are the Razor views you are using. For example, the main page there, it's the pages index Razor. Those are files with Razor extension, and they are very similar to those Razor pages or Razor views you already know from MVC or from the server-side ASP.NET Core application. There are some specifics. For example, the basic Razor page does have just this Razor markup code. It's kind of spaghetti code where there is a HTML markup mixed with C#. But the specific here is that Blazor is based on a component model where every single piece of user interface is a component, very similar to those components known in React. And by the way, the whole Blazor is the original development was inspired by React and Angular and Vue.js, by those front-end frameworks. So the concepts there are very similar, and the components you are building here, they are then rendered into the application itself, and there are basically two types of components, or main types of components. These can be pages, where they have page directive there, and the part, the segment here you have to define is the root you use for the address of that page, and there is a router component which does not have any like individual output, but it's in the root file, which is the app Razor, and this router component is responsible for resolving the URL and finding that specific component which matches the root prescription or whatever it is, and renders that specific component to the DOM, document object model. The second type of component are the other child components you are able to use within those pages, and these are just regular components like for example here in the index Blazor, the main page, I've got, for example, the pager component here, which means that there is a individual pager file, page eraser, which defines the user interface, the content of that specific component, and the behavior. The whole programming model is based on MVVM, model, view model pattern, and it's very similar to Razor pages or web forms. So basically you've got piece of HTML and then you got some supporting code, and the whole compiles into single class. You can put the code in a separate file by using inheritance. For example, this pager component inherits from pager base, which means that the code for that component is in a base class. Every single component can have parameters. Those are properties. They should be private or protected for some specific reasons we can discuss separately, and those parameters are then usable as attributes. So for example, from the index Razor file, which is this one, the data and on-page changing are those two parameters of the pager component. There are two or three basic types of parameters, like the regular ones, where you pass data. These can be passed in both directions, but basically you pass some data to the component. And then there are events. The events are very simple. The definition of the events is very simple. You just have to create property with the parameter attribute and use event callback as the type of the parameter. It's a generic type, and the type parameter here is the type of the arguments passed within that event. So for example, this simple pager event, it gets some data and renders itself using this HTML code or Razor code, and those client events here, for example the on-click event, are handled by the C# code of the component itself. It's the change page method, this one, and if I want to propagate that event to the high level component, I would just create the arguments and call invoke async. Most of the APIs there in Blazor do have two alternatives. You usually got the basic and the async version of every single method there. So this is how you pass the page changed event to the high level. So for example, in the index razor page, there is the page changing event handler. This is the basic syntax where you don't use the code behind file, you don't use any specific base class, you don't use the inherits directive, and that means that there is a default base class. It's the it's the component base class. So this is how you write the code of the component inline if you don't want to use the code behind approach. And the current version, it's maybe not the 6th version you already tried, they are changing this directive from functions to code, which will be code. In the current preview, both should work, functions and code, and in some time in future the functions will probably stop working and it will be only code.
It already says code in the new campaign.
Yeah, right. So what we've got here, every single component has some basic life cycle. There are some stages of the life cycle. So maybe I will use the slides here. I've got some there. We'll skip these. Maybe we can get to some of those later. Back. It was these are the lifecycle methods. The very first one is the constructor, then it's the onInit method at the very beginning. Then we've got the set parameters with parameter collection. This is a method you are able to override, and this is the method where the parameters are passed from the high level component to you, and you can manipulate those parameters before setting them to the real properties. And then we've got onParameter set, which is just like a placeholder you can override. Then there is the should_render method, which by default returns true, but you are able to override that and tell the whole engine that you don't want to re-render the component. Then there is the build_render_tree, which is a very specific method. It contains the render logic itself. So that means that the markup code you write in the Razor file, so it's this code, which is like not wrapped in any specific directive. It's the markup code which is compiled or translated into C# code, and this code becomes the content of the render or build_render_tree method. And if you want to write your own component without the Razor file, just by using code, you can override this method and implement it on your own. So for example, for this index page, there are two other components, the time and the plain text, and these exist just as coded components. For example, the time, it does not have any time.razor file, it's just a class, inherits from component base, then you've got the parameters, and then there is the override of the build render tree method, where there is the builder you can use to render the whole component. And this is the code which is usually generated by the Blazor builder or the build itself before the compilation from the Razor file. It generates the C# code. And there are many methods like add content, add attribute, open element, open component, close element, close component, and by using these methods on the builder, you build the component tree, which then translates into the, well, if it comes to rendering, it works very similar to React, as it creates virtual DOM, virtual document object model, and then it compares the virtual DOM with the real DOM, and just or the comparison there is not with real DOM, but the comparison there is in between two versions of the virtual DOM, and as it detects changes, only those changes are written to the real DOM as a performance. It's not just for performance reasons, but you don't want the user interface to get re-rendered as whole, but you want only specific pieces of the user interface to be re-rendered in the browser. So, but it's very similar to those front-end frameworks you already know in JavaScript. You might ask what these numbers are there. It's called sequence. If this code is generated from the Razor files, these numbers are in fact the row numbers in the Razor file. So it's just, there is a specific instructions. You should not generate these files, these numbers from any incremental counter, but you should use constants there. These numbers are then used when the diff of the virtual DOM is being created, and it's used for effective comparison of those two versions of DOM to get the difference as quickly as possible. So what we've got there, if you want in Blazor, if you want to create, there are only very few built-in components. We saw the router, which does not have any individual HTML output. It's just responsible for rendering and finding the right page component to be rendered. And then there is one single specific component called navlink. It's I can show you the layout file here. And by the way, the layouts are very similar to those layouts being used in MVC or Razor pages. You just create a file like any other component. There is a specific base class called layout component base, and this just adds the body property there. You can use where you want to render the body, and then if you want to use this layout for any specific page, then you can add the layout directive in that page, or you can use those imports Razor files, which are similar to, it was called view imports in Razor pages or MVC, where you were able to define those common layouts and usings and stuff like that. So in this case, this means that this imports Razor file becomes part of the C# class being generated for every single component in this folder and all the subfolders. But you can create a separate imports Razor file in any other folder, and this is being used by those files. But what I wanted to show you, what's in the main layout, I've got my own component here, the menu component, and in the menu component it uses this almost only one built-in component in Blazor, the navlink, and in fact it's nothing else than regular anchor with a specific behavior where it communicates with the router component, and it tries to find the match in between the current route and the route defined here, and if it finds the match, it will add active CSS class to the anchor elements behind that. So this is currently, or why it's there, it allows you to define style to mark that specific section in menu where you currently are in your application. And then all the other components there, it's the only second area covered by Blazor is a very basic form with validation. So for example, I've got here this questions page or questions component, which does have a simple form. The form there, it uses those few components built in Blazor. There is the edit form component, which allows you to set the model, which defines the data annotations used by the form, or of the model used by the form. And there is then the onValid submit or onInvalid submit or onSubmit 3 events you are able to handle in those three situations where the submitted form is valid or not. It's cooperating with the other components here. The most important one is the data annotations validator here. There is an intention that they will create more of these. This is currently the only validator implemented which uses the metadata from data annotations from the model. Those attributes on properties, for example required and range and stuff like that, and uses them for the validation. And then there are the individual inputs. They are currently there is only very basic implementation of those inputs. For example, the select input currently does support only string values, and it does not support integer as values for those options, but it's under development. And within the edit form you usually use the binding syntax, because Blazor does support bidirectional binding, but it's in fact just a syntactic sugar, because this bind is nothing else than the value is being assigned from the model, and then there is the on change event where there is some very basic implementation, like something like this, where the new category ID so this is the full syntax. This is the full binding with some type conversion which has to happen there, but this is the full binding happening there, so it's the very same if you write bind value and delete this. And in fact you can delete the value as it's the default for binding, and it's currently this should be enough. So this is cannot be interfered. The type of component, who knows? So it's probably not there. Then, as you can see, there are some specifics. The data being used here, it comes from local fields of the class. For example, this questions raiser, I've got the code behind file here, and in the on init async I am loading the categories and loading the questions. So this is the page we are currently talking about. These are the categories and these are the questions, and if I reload this page, it tells you for some short while that it's loading. This is all about the asynchronous way the whole Blazor rendering engine works. So for example, as you are loading all these data, the component itself is already being rendered, and as the categories are not set yet, has not been set yet, it says loading, and it's the same for example here for the questions, and as it becomes loaded it then renders just after that. So then there is a third, it's not type of component, but it's some specific feature you can use in your components. You can refer to the content, inner content of the component, how it's defined. This is if you want to use something like, if you want to implement something like this repeater, where there is a template for the header, template for the item, and template for the footer. It's pretty simple. I've got the whole implementation of the repeater here. You just create parameters of render fragment type, and there are like 3 types. There is the simplest one is if you name the parameter child content, it just gets the full content of the component. If you use any specific name, then it allows you to create individual templates or segments or fragments. In fact, it's called fragments, where these have their own name. And the third type, the third specific here, is that you can use the generic version of the render fragment class to create a template which does have some input parameter, which then you can use it to render the template using this parameter. So for example, this whole repeater is generic. When it compiles, it gets a generic parameter, type parameter t-item, and I then use this type parameter for the generic type of this item template and for the generic type of the items collection here. And the code used for rendering this whole repeater is pretty simple. It's just the iteration and rendering the fragments itself. So this is how you use it. You set the items, and then in the item template you can use the so-called context. In this specific scenario, I called that context item. If you don't define this context, you have to use the context field, it's probably a field or property, to refer to the parameter you are iterating over. And you can put there any name you want. So if you rename the context to, I don't know, James, then you can use James instead of those contexts. So the very last thing I would like to show you is the JavaScript Interop in between Blazor and JavaScript. Blazor is able to call almost any JavaScript function from Blazor to the Autoboard. It does have to have just a few, it has to meet only a few conditions. It has to have JSON serializable input and output, and it's being looped up in the window context. So for example, if I got this index file which hosts the whole application, this is the file which is being used as the application gets loaded. If I go to the browser and if I show you the source code, it's this index file. And Blazor currently does not have any built-in feature which would allow you to manipulate this title of the page. And if I want the title to get changed as I'm switching in between those pages, I can do that using the JavaScript Interop. How you do that? I've got a JavaScript file, my own custom JavaScript file here, and it does one of those functions here. It's the set page title. It just sets the title, and now I'm able to call this function from Blazor. So for example, from every single page I'm calling I'm calling this JS helpers service, the set page title, and this is my service. There is a regular dependency injection like in any other ASP.NET Core class, where you can use either the inject attribute on your properties, or you can use the constructor injection. This property injection is usually being used by the components, and on any other service you use the constructor injection. And the JS helper service I've got here in services, and it's registered in the startup class in the configure services, just as any other regular service, to the dependency injection container here. The service, there is a JS runtime service available in the container. You use this JS runtime, and there's the invoke async method, where you pass the name of the function and the parameters. The generic type here is the type of the result. So in this specific case I do not expect any result, that's why you just used object. And this is how you are able to call any JavaScript function from Blazor code, from your C# code running in browser, communicating with the other JavaScript there. There is an opposite way where you are able to call Blazor or your .NET method from JavaScript. There is the .NET class, and on that .NET class there is a invoke method, kind of that. This is already went through. This is already seen this. Data binding, templated components. This is the one. This is the from Blazor to JavaScript, and this is the opposite direction, where you have on the .NET class you have the invoke method, where you pass the class name. If it's the static method, you pass just the class name and the method name, and then the parameter. If it's the instance method, you have to pass reference to that instance from Blazor to JavaScript by using the Blazor to JavaScript call. You can use the .NET object ref type to get the reference there, but I guess you don't want to call .NET from JavaScript, and you have to mark those methods you want to allow to be called by the JS invocable attribute. So basically that's it. It's just a regular front-end application creating its user interface using HTML, but you don't have to use any JavaScript to write such an application. You code the whole application in C# using Razor syntax and the whole component model there, and the application is then running in browser using the WebAssembly engine there, which is part of the web standard, so it's currently supported by most browsers, and it's just running. It's currently the state of this whole technology in Microsoft. It started 2 years ago or 3 years ago, there are currently two separate hosting models for this. Everything I showed you today is the so-called client-side hosting model, where the code of this front-end application is running in browser on WebAssembly. But there is also an alternative model called server-side Blazor, where they used the protocol there they are currently using to communicate in between the Blazor running in WebAssembly and that JavaScript which updates the document object model, the DOM there. They used this communication protocol and made it work remotely. So in the server-side hosting model, the Blazor application, all that C# code there, is running on server side on your server, and the client side does not use any WebAssembly. It's the JavaScript. It's only the JavaScript there, and the JavaScript communicates with the server using the signal-air technology, using WebSockets, and all those events which are happening on client side you are subscribed to are passed to server, where there is your application running in the very same way as it would be running in the browser. It processes the event on server side, and all those resulting changes in the DOM are being sent back to the client, where the real DOM in the browser is updated and the user interface is re-rendered. From my point of view, this approach is not how to call that. I guess that there will be major issues with scalability, with the state management, where the Blazor application running on server, there has to be a new instance of the whole Blazor application for every single user connected from the client. So every single user which is simultaneously using the application has its own application instance on server side. It holds the whole state of the application on server and just kind of mirrors the user interface to the browser, and whenever you lose the connection it just breaks. So it's usable, I would say, just for the only nice thing there is that the code of the Blazor application is the very same code you use for the client-side mode. So the very same code, the very same application you are able to run in these two modes, on client side where the Blazor application is running in browser on WebAssembly, or in the server side model where it's running on server and communicating using this signal-air. And this might allow you to use the debugging tools and all that kind of stuff in the server-side mode to be able to debug the application during development, and then switch the hosting to client-side and let the application run on client. Because currently there is a very simple kind of proof of concept way of debugging the application running in browser. For example, this one, if I use the magic key combination Shift Alt D, it maybe, it's not. No, it's interesting. It's the, I'm not running the debug version, it's the production version. So if I run it from the browser, from the local Visual Studio in debug build, now I should be able to hit that magic combination Shift-Alt-D to run the debugger. In the very first try it tells you that the Chrome is not running in debug mode, so I have to switch Chrome to debug and just take this command. I have to close all Chrome windows. There might be some others still running. No. And now, by using the debug mode of Chrome, I can use Shift-Alt-D again. And now, fingers crossed, it runs the debugger, and I'm able to debug C# code running in browser on WebAssembly. So for example, I've got a breakpoint here for the page changing event in the questions razor file. So if I go to questions and change the page, I should hit the breakpoint, and it now tells me it's post in debugger. And now I've got the application here, and I can step over. There is the watch window, I've got the call stack here and everything, but it's super
fragile.
Fragile is yeah, it's a fragile, kind of fragile. Yeah. For example, as it's most of the stuff here is async, if I go to step the next function, it's working, and now it probably stops somewhere, maybe here. So it's just kind of proof of concept to show you how this might or how this will look in the future. On their roadmap, there is definitely that they want not just to be able to debug Blazor in browser, but they want to be able to attach Visual Studio to the browser and debug Blazor right from the Visual Studio, which is probably what everyone wants. So the very last thing I can show you is probably the roadmap. This is what is currently already implemented. The server-side Blazor model is almost production ready, and it will be part of the ASP.NET Core 3.0 release in August or September, or will be released this day. And the client side will be probably part of the next .NET major release, which should be probably November next year, and it will be the .NET 5. And this is what I want to support. The authentication and authorization, you already said that it's there in the preview 6. Live reloading. So currently, whenever you change anything in the Blazor code, in those Razor files, to get it into browser, you have to compile that and reload the application in the browser, which in fact restarts the application, and you have to start from scratch. This will allow you the very same experience of live reloading you already know from front-end development, where whenever you change anything in Visual Studio or in the source code, it gets automatically updated in the application live running in browser. Server-side rendering, it's not that server-side hosting mode I already mentioned. This means that currently, if you visit the web running or based on Blazor, you get that index file which is almost empty. It's just the app root element there, and the whole rendering happens on client side. The server side rendering means that you will be able to switch on server side rendering, where the Blazor application will render the HTML code on server, and the HTML file you will get from the server in the very first request, within the very first request, will be already pre-rendered to that version of user interface you would or you should see by running the application. And then on server side the application is stopped, or it's not being used anymore. It's just for the very first request to allow the HTML to appear, which makes the user experience better, as it's usually means that HTML the page is being displayed quickly or quicker, and it allows you to support search engines or search engines optimization, where you will have the content for those search engines. Full .NET debugging using Visual Studio. Rich IntelliSense is almost there. As you saw, I'm able to use IntelliSense like in any other Razor file. Publishing and app size streaming, it's already there and it should be better. The long-term vision or approach is that they will want to compile those DLL files, those .NET assemblies, so that they won't need to compile them in the .NET runtime in the browser, but the downloaded assemblies will already be in the WebAssembly code. So it's similar to what it's known in .NET like NGen, the generating the native assemblies from the .NET code. And that's it. It's currently, as you said, fragile. I would say that the very first production attempts, just for some internal administration websites, might be real somewhere in August, where the .NET or ASP.NET 3.0 will be released to release candidate and getting ready for production. And as the production version of .NET 3.0 will contain the server-side Blazor, it should already have the stable version of all those components and life cycles and stuff like that. It's just the .NET runtime running in browser which is waiting for the stabilization, because the current mono .NET runtime there, it's just kind of proof of concept written by that Miguel from the author of Mono, and they will want to unify .NET into a single .NET thread. They will probably want to replace this Mono by the unified .NET runtime, probably based on Mono in this specific area, but should be the same code base. So that's it. Thank you for your attention, and do you have any questions? Yes?
This is more about question more about MVC. I'm just curious how long it took for MVC to develop into publishable state for production.
In case of MVC, it took them 2 or 3 years, but the team working on that was a little bit bigger. This Blazor project started 2 or 3 years ago as a work of two developers in Microsoft, as like a research project, as they didn't want to let the WebAssembly approach undiscovered, or that there is kind of a potential, and they wanted to like know the details and create a kind of proof of concept. And till April or till it was in probably in January, where they decided to join the Blazor team, let the Blazor team join the whole ASP.NET team, so they became part of the ASP.NET team with much bigger resources. And in April this year, they got rid of that experimental project label, so it's no longer experimental. It's currently like there is a statement written by Microsoft that they are committed to deliver like a production version of client-side Blazor in one of the next .NET releases. So it's still not promised that it will be .NET 5, but it's expected.
And, another question: do you think that the Blazor or the .NET framework might get implemented in the browsers itself, that it would not rely on WebAssemblies, for example, like JavaScript does?
No. It's just a simple answer. I think that this WebAssembly specification will get new features. For example, apart from that lack of ability to communicate with DOM directly, there are other like issues. The major one is with memory management, where there is currently no garbage collection or memory management feature. You just get the whole memory as a large array of bytes. You have to manage or on your own. So what's currently the mono runtime doing? It's executing garbage collection and all this stuff on its own. But as far as I know, it's able to collect or manage just the memory it gets from the browser. But once you ask for the memory from the browser, you are not able to return that memory. You just have to leave the page and let the WebAssembly process die to be able to return the memory to the browser. So the current implementation, as far as I know, there is a limit of 128 megabytes, which is which it is able to ask for, and those 128 megabytes is managed by Mono, and whenever you need less, it's not able to return that memory to the browser, and whenever you need more, you have to configure the limit in advance. So it's kind of tricky in this area. If you have some more sophisticated logic in the front-end application, except the UI rendering itself. So you really should not do any like memory-intensive tasks in the browser except that UI rendering.
And how much of the memory takes the Mono?
The Mono itself, well, I don't know, but it will be probably like only several megabytes. Because the WebAssembly of Mono itself, it has 900 of kilobytes. And then it needs something for the runtime. I don't know. But with all the experiments I made, I was not able to hit the out of memory exception or anything like it. If you run in debug mode, you will see the garbage collection events in the console of the browser. So it's being reported by Mono, which is sometimes funny as you are running the front-end application and then you see that it's garbage collecting. But it seems to be working, at least for these simple UIs, and we will have to try. And the good thing there is that there are at least two promising things. Microsoft itself is using Blazor for running .NET code for try.net and for docs Microsoft.com whenever you are trying. There are some tutorials and stuff like that on docs Microsoft.com, and on try.net it's similar. There is the .NET Fiddle created by Microsoft. Should be much quicker. Yeah, this is. Oh, oops. Let's see. So on try.net there is the .NET Fiddle, where you are able to type any .NET code you want to try, and Microsoft used to transfer this code to server. Then it was executed on the server, and the result got back to the browser. And now they switched to Blazor, and whatever you are trying here is running on that Mono engine in Blazor here on client side. Right. So we can, if I do the refresh, you will see that it's loading some version of it's the Blazor here, the Mono here, and Microsoft said that by switching to this client-side mode, they save, I think it was $100,000 per month just for this. For the resources they saved on the server side. So it's quite a saver. And the other promising thing is that the authors of the major authors of web components like Telerik, DevExpress and those, they already started developing Blazor components. So should mean that they also believe in such approach, and that we will have components to use in applications. There are many Blazor open source projects. For example, there is the Redux version for Blazor for the state management of the whole application and stuff like that. Any other questions? Your opinion on such an approach? You like it?
I find it hard to get over C# code in the client application, in the front-end application. I mean.
You like the JavaScript there?
No, but I just I have associated C# with more backend approach, and then when Blazor came and showed us that it can be also possible to develop the application for front-end in C#.
So you mean it's too sophisticated for the front-end application?
It's too good for front-end.
Too good for front-end.
I like the
So
idea,
don't tell anyone.
I like the idea that you can use the same model on both.
Yeah, this is something I didn't stress. The application here, if I add Blazor or if I create a new Blazor template, and in this case I added Blazor to existing solution, one of those templates is that the Blazor itself is a client-side application. Whatever you create in Blazor, this is the Blazor client project, it's being compiled in design time, and the result, these are just static assets you are able to put on any, I don't know, for example, Azure storage account and serve them from that. So it's not running on server or being manipulated on server anymore, and everything happens on client side. But if you select that so-called ASP.NET Core hosted template, it creates the server for you, and the very basic configuration there is that it just serves the result of the client build to every single request it gets. So no matter of the URL, whatever I put in here, and if I clear here, so whatever I put here, it gets the Blazor application from server. It serves the application. With the only exception, if I create any custom route on that server, for example, if I add some API there, REST API usually for the application, it's being handled by those controllers and actions for that API, and all the other URLs are passed to Blazor. So this allows me to host the application on server, add some API to the application, providing data, and I can use, for example, the third project, which is part of the template, which can be then referenced from both of these. I can reference the same shared project from server side, from client side, and for example all these data transfer objects like view models, input models can be shared in between server and client, and we can get rid of those generators of TypeScript interfaces or whatever we are currently using to generate the front-end code from the server code and stuff like that. So for example, I've got the controller here for the questions, and it uses the question list item view model here, and it's placed in the shared library, and I use the very same class in this questions clients facade here as the result of this get questions async method, where I get just pick the results from the API and use the very same classes for deserialization. That's it. So thank you for today and see you next time.